Hello YouTube, this is UMOZO3. We've been building up an understanding of frozen dictionaries, and we said this is not typically a class that's provided standard in Python. It's something that we have to implement using a class. And so from lines 5 to line 61, we talked about multiple methods that we created and implemented in order to use a frozen dictionary. We're talking about a collection of immutable key value pairs. Okay, so we have a constructor defined in it of my dictionary, and we said that we can base a frozen dictionary on a dictionary, just like we based a stack or queue on a list. Okay, so hopefully that's clear to you, but we just say self.dictionary equals my dictionary and then define length of self. Just in order to get the length of a frozen dictionary, we'll just define that to be the length of the dictionary on which the frozen dictionary is based. And then we could get an item out of the dictionary, obviously. So we could say if it's not the case that item is in self.dictionary.keys, return not in the dictionary. Otherwise, return self.dictionary of item. So basically, this allows you to treat a frozen dictionary as a dictionary to get values out of by passing in a key. And here the key is being referred to as item. That's the name of the parameter. And then we could say set item, but usually we would just return a type error for that because we said we cannot modify an immutable data structure. Okay, so here we would be talking about tuples, frozen sets, or here frozen dictionaries. Hopefully that's clear to you. And we'll probably get a Python enhancement proposal saying that that comment is too long. But anyway, we also have a get method. So we could say, for example, x.get of y for some frozen dictionary x and key y to get a value associated with key y. Right, so hopefully that's clear to you. But if it's not the case, the item is in self.dictionary.keys, return not in the dictionary. Otherwise, return self.dictionary of item. And then we have a string representation of a frozen dictionary. We can see if an item is in the frozen dictionary, so return a val of item in self.dictionary.keys. That'll just return true if the item is one of the keys in the frozen dictionary. But what if the item is one of the values in the frozen dictionary? Well, we have a separate method for that. So define contains value of value, return value in self.dictionary.values. And then we can add two frozen dictionaries together. So new frozen dict equals dict. That's an empty dictionary created on line 39. And then for k in self.dictionary.keys, new frozen dict of k equals self.dictionary.get of k. For v in other.dictionary.keys, if it's not the case that v is in self.dictionary.keys, new frozen dict of v equals other.dictionary.get of v. Okay, so do not add a key value pair if the key is already recognized. So hopefully that's clear to you. But q equals frozen dict of new frozen dict. So this basically calls the constructor, and then we could return q. So we'll just return the resultant frozen dictionary, but it's still going to be an immutable data structure, even though we created it by adding two frozen dictionaries together. And then we have a class method and a static method, which respectively create an instance of the class. So they would just say return frozen dict of my dictionary, depending on what dictionary parameters brought in to either of those methods. But those are static methods and class methods, and now we've seen ample examples of that throughout this curriculum. And then we also talked about a subclass, right? So the other thing we added on in this video, what I wanted to do in this video is review the callable, so callable function. So callable is a standard function in Python. It shows up in purple, just like int and print and map and filter and a bunch of other functions, but we say define call. So there's only one magic method in this subclass, but in line 64, we basically declare that callable frozen dict is going to be a new class, but it's going to inherit all the functionality and methods from frozen dict. So callable frozen dict gets to do everything that frozen dict can do and then sums, because we say on line 65 define call of p. So if p is in tuple of self.dictionary.keys, return self.dictionary of p. Otherwise, return that key is not in the dictionary. And then we could go ahead and run some examples here. So I think I have some examples printed on the console. And then we can also, again, review the eval. So one more time, we could say exec of c equals 10, print eval of c dot lower, that gives us 10. But print eval of c concatenated with plus, concatenated with 5, that gives us 15. And then y equals carets, my length equals 0. For z and iter of y, my length plus equals 1. Assert my length equals length of y, and that gives us a true boolean. That's why there's not a runtime error. And we try it again with a list of iter of y. So my length equals 0, z equals list of iter of y. For k and z, my length plus equals 1. And again, there's no issue with asserting that my length is equal to length of y. That's a true boolean. And then z equals iter of y, my length equals 0. While true, try s equals next of z, my length plus equals 1. Except stop iteration, pass, and break. So assert my length equals length of y, and again we get a true boolean. There's no issue printed on the console. And then we can review JSON, right? So we said we have to import the JSON module, so import JSON as J, and that basically allows us to convert a string that wraps a dictionary inside of it into the actual Python dictionary and vice versa. So then if we scroll down here, we say define JSON object of S, return j.loads of S, because we said loads is a function from the JSON module that accepts a string containing a dictionary and returns the dictionary, and JSON string does the opposite. So this is a lambda function defined on one line. So lambda w, return j.dumps of w, because we accept a Python object like an int or a dictionary and return the JSON string representation of that. It's the opposite as this, it's the opposite of this function. But my dictionary equals map A to 95, map B to 85, map my number to 85, map 84 to 85. My dictionary equals JSON objects of my dictionary, print length of dictionary, length of my dictionary, and then that would give us 4, right? Because it converts this string into a dictionary. And then my dictionary dot update of C with 75, and then print the dictionary, so you can see that key value pair makes it on. And then my dictionary of D equals 65, and then it's another key value pair coming on. For Q in my dictionary, if my dictionary dot get of Q equals 85, print Q, so we see that 2 keys provide a value of 85. It's either B or 84, because my number was popped from the dictionary. That key value pair no longer exists. And then again, S1, S2 equals 82, 84, S3 equals 100 times S2 minus S1, S3 equals JSON string of S3, print length of S3 concatenated with S3, so that'll be the length of the string 200200, which will be 6. And then print length of my dictionary equals length of JSON string of my dictionary. Clearly that's false, because there's going to be way fewer key value pairs than characters in the string that represents the dictionary. And then A equals 323, print type of A, it shows us that's a tuple, but print type of JSON string of A, it shows us that's a string. And then exec of Z equals, this is a very, very long value in a very, very short dictionary. Short dictionary, map the key 2 to the value Z. So print length of short dictionary equals JSON string of short dictionary, so that would be false, right? Because there's only one key value pair in the dictionary, but then in the string, there's tons and tons of characters. And then we can review frozen dictionaries, right? So dictionary T equals 1, bool of 1, 0, bool of 0, potato 5.75, 5.75, tennis, soccer, tennis. So there are 2 keys that are being mapped to the same value. So print length of dictionary T, that just gives us the 5, and then print dictionary T of potato, 5.75, but then we can convert it to a frozen dict. So we say frozen dict equals frozen dict of dictionary T, print length of frozen dictionary T, print frozen dictionary T of float of 5.75. So these outputs are appearing on the console, 5 and 5.75. And then print frozen dictionary T dot get of soccer. Well, what would that return? That would basically return the tennis. So that's what you see here, right? So hopefully that's clear to you. And then print potato in frozen dictionary T. Well, then we get a tennis, right? Well, then we get true, right? That would be true, because that's a key in the frozen dictionary. But then print tennis dot lower in frozen dictionary T, that returns false, because we said our contains magic method returns true if it's a key in the dictionary, not a value in the frozen dictionary. It has to be a key. And then frozen dictionary U equals frozen dict of potato with 999, summer with June, July, August. Frozen dictionary V equals frozen dictionary T plus frozen dictionary U. Print frozen dictionary V, so we can see that the potato value did not get replaced, right? It's still 5.75, because that's how we defined our add magic method. And then we could say there's a couple other examples of that you can go ahead and review in the previous video, right? If we say frozen dictionary W equals frozen dict dot class method frozen dictionary of 335, print frozen dictionary W of 3, that gives us the 35, right? That's right here. But then if we say frozen dictionary X equals frozen dictionary W plus frozen dict dot static method frozen dictionary of 3 with stinky socks, print frozen dictionary X dot get of 3, we get 35 again, because the value is not replaced. And then we talked about the callable magic method. So we have another subclass, and we said the subclass of the frozen dict class is called callable frozen dict. And the only other thing that it supplies is a call magic method. So then if we go ahead and scroll up and we say print, and then so we can say frozen dictionary Y equals callable frozen dict. And then we pass in the same input, we pass in a dictionary again. But we say print frozen dictionary Y of 9, and that would give us 90. But then if we say print frozen dictionary Y of 4, that gives us that key isn't in the dictionary. So basically, this would be the call magic method of the subclass, right? So we could stick an input into a callable frozen dict and get an output out, but we couldn't stick an input into a regular frozen dict because there's no call magic method in the superclass. There's only a call magic method in the callable frozen dict subclass. So then if we say print callable of frozen dictionary X, that gives us false, but print callable of frozen dictionary Y, that gives us true, right? And then we saw some other examples, right? So then I guess if I scroll down here, we also have a method called, let's see, what else do we have printed on the console? Okay, so print callable of map. So that gives us true because map is callable. Print callable of float, that's true. Print callable of print, that's true. W equals 177, print callable of W, that would give us false. So the point is that callable is a standard function that returns true if X is a function or an instance of a class that supplies a call magic method, right? Because that basically makes the instance a function and then it's callable, right? But that's how callable works. What we're going to do in this video is talk about hex numbers. So basically there's another numerical data type in mathematics and computer science called hexadecimal. And you might already be familiar with it from a math or computer programming course, but basically hexadecimal numbers go up to base 16, right? So we talk a lot about decimal numbers, and we say that decimal numbers have 10 digits, right? We can either go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. With hexadecimal, there's 16 digits, okay? So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, okay? So there's 16 digits, okay? So if you saw a hex number with 1, 0, that actually corresponds to a decimal number 1, 6, right? Because we said 1, 0. Basically, every time we have another significant figure in a hexadecimal number, that would be a factor of 16 rather than just a factor of 20, rather than just a factor of 10, right? So if you see a hexadecimal number that says 40, well, really that would be a decimal number of 64, right? Because 4 times 16 is 64, but we can go ahead and study the hexadecimal, right? So Python actually has a hex function, and you don't have to know too much about it, but we can go ahead and learn a little bit about this. So it converts an integer number into the corresponding hexadecimal string. And I guess you can learn as much about hexadecimal numbers as you want. Presumably there will be a helpful Wikipedia article, right? You just go hexadecimal. In mathematics and computing, the hexadecimal number system is a positional numeral system that represents numbers using a base of 16, unlike the decimal system representing numbers using 10 symbols, right? So hopefully that's clear to you, but we go 0 to 9, and then we go A to F. And I want to show you basically how hexadecimal numbers can be represented in Python, right? Binary is a very important number in computer programming, right? We normally think about bits and we think about zeros and ones. Okay, but with hexadecimal numbers, we're not just thinking about 2 options, we're not just thinking about 10 options, we're thinking about 16 options, and the 16 options are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, so F essentially represents 15, B essentially represents 11, 7 represents 7. Okay, hopefully that's clear to you, but we would refer to it as base 16. So it says it's used in the transfer encoding base 16. Okay, so hopefully that's clear to you. It's pretty straightforward to go back and forth between binary and hexadecimal, but it's not as straightforward to go back and forth between decimal and hexadecimal. But luckily, there's a function called hex of x. Okay, so it's hex, H-E-X, and it shows up basically as purple, right? And so that we can see whether it's callable, right? So we could say print callable of hex, right? So it's just another review of this callable function, the standard function that we have available to us in Python. But what we're going to do is think about the output here. So we defined hex numbers, just a function defined on line 225. And this is not really a formal doc string, right? So you could go ahead and fill this out, but we could say this function tests the hex standard function in Python in order to increase understanding about hexadecimal numbers in Python. So it turns out that we can actually take an int into a hex, and we can go back and forth. We can think about taking a hex back into an int. Okay, we could think about taking a hex into a Boolean. We could think about taking a hex into a string. So let's think about how we would do some of those things. So first, what we're going to do is we're going to say print hex of 5. So basically what you have to understand is that 0x will show up as the beginning of the result of any hexadecimal number. And that's typically what we do in mathematics and engineering, is in order to signify that a number is being expressed in hexadecimal rather than decimal, we typically write 0x. And that's why you see that printed on the console several times, right? So on line 234, we say print hex of 5, and that gives us 0x5, right? Because of the hexadecimal representation of the number 5 is just 5, right? That's a small number. And just like we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can also go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. But the point is that 5 in decimal is actually the same in hexadecimal, it's just 5. But what if we say print hex of 30? So that basically gives us 1E. So let's think about what 1E means. So 1E. So basically E means 15, and 1 is one figure on, so E is actually 14. So E is 14, and 1 is one figure on 16. So 16 plus 14 is 30, right? So that's why print hex of 30. That's why that gives us 1E, because it's like 16 plus 14 is 30, right? We said hexadecimal goes up to 16. So we have to fill as many 16s as we can before we go on to the next digit. In order to do that, we have A, B, C, D, E, F. Literally, those are digits, right? It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. It's 16 digits. And then on line 237, we define a lambda function. So we say H equals lambda x hex of x. So basically, H of x will work the same way as hex of x, right? And then I guess alternatively, could have used a function reference variable, right? So I guess alternatively, we could have said H equals hex, right? But it's another way to do the exact same thing. But we could say exec of print H of 892. So what is the hexadecimal representation of 892? So that would be 37C. Okay, so let's think about why that's the case, right? So you can think about that on your own, but that would be like 16 times 16 times 3 plus 16 times 7, and then C is 12. Okay, so let's think about what this would be. But 16 times 16 times 3, well, that would be essentially 768. And then 16 times 7, well, that would go ahead and be 112. And then we would go ahead and have 12. But that would, in fact, be 892. But that's the hexadecimal representation of the number 892. Is it's 0x37c. And then we could say print int of 0x55. So we can actually, so just like we can take an int into a hex, we can convert a hex to an int, okay? Specify 0x. You can say print int of 0x55. So if you had a number that was represented as 55 in hexadecimal, what would be the decimal representation? Well, the answer is 85. That's what's printed on the console, right? So you can think about that, because 5 times 16 is 80, and then 5 times 1 is 5, and 80 plus 5 is 85. We could also convert a hexadecimal number into a float. Okay, so basically, if you say float of hex, basically what this does is it does float of int of hex. So basically, it essentially has the effect of converting the hexadecimal number into an integer, and then converting that resultant integer into a float simply by adding 0.0. But you say print float of 0xf3b, and that will give us 3,899.0. And then you could say print string of 0x2b. So this would actually be a string. So this would be the string 43, right? So if you said print length of string of 0x2b, that would give us 2, right? Because there are 2 characters that make up the string 43. But the point is that you can convert a hexadecimal number into a string, right? And then you could say print bool of 0x00. Okay, so bool of x for a hexadecimal is 0 if the hex is 0x00, so essentially 0, and I guess would be true. It would be false, okay, and true otherwise. So if the hexadecimal number is anything else, you get true. So that's why bool of 0x00 you get false, but bool of 0x01 you get true. And then we could say print type of hex, and it says built-in function or method. But print type of H, remember H was a lambda function we defined on line 237. So we say print type of H, and it says class function. Okay, and then we could also say print callable of hex. I guess that didn't really make it onto the console, but we could go ahead and run it. I guess we're going to have some invalid syntax when we were talking about this earlier, but we could go ahead and run it and just make sure that hex is callable. And indeed, hex is a callable function because we can pass an input into it. It's callable, we can call it. So hopefully that was interesting to you. We'll talk more about hexadecimal numbers and frozen dictionaries in the next video. From me, Mozo3, thanks for watching and please subscribe.